Hello, everyone. Thank you for tuning into this episode of the Amazing Podcast. I'm Twain Taylor, editor at Amazing, and I bring you discussions almost every week with someone who is building something in the space of Kubernetes and cloud native. And we enjoy talking about those topics. So if you like listening to this and this is what you do day in and day out, then head over to our website. It's amazic.com. That's amazic.com. You'll find a whole treasure trove of conversations like we're going to have today. And you'll also find a bunch of other stuff like event coverage, the KubeCon, and other events in the space. We also have articles. There's a whole lot of stuff. So definitely head over to the website there and check out all that we have. I'm excited about today's conversation. It's going to be around observability and monitoring, and with a touch of AI. So it's going to be really interesting if that's something that's been on your mind lately. I'm going to be speaking today with Alois Reitbauer, who is the Chief Technology Strategist at Dynatrace. So if you've ever scanned monitoring tools, observability tools, and if you thought of using one of them, you've probably come across Dynatrace. They've been around for really long, and yeah, one of the really significant companies in this space. So I'm quite excited to be talking to Alois, who focuses on product for Dynatrace. Alois, welcome to the podcast. It's great to have you with us.
Thank you for having me.
All right, Alois. I was wondering if you could tell us a bit about yourself as we get started and just your time at Dynatrace. I think you've spent quite a few years with Dynatrace. Tell us a bit about just, your time with the organization from start to now, some of the key milestones.
I think the key milestones for me were also like major technology milestones. So I joined the company like roughly 17 years ago. So in the tech world, that's maybe the essential
Yeah.
most. So when I started, it was really the time where people started to work with like larger distributed applications. Back then, JE was the technology out there. Like back then, environments for 100 servers were large, and we were just entering that more distributed environment, SOAS and so forth. And when I joined Dynatrace, the major challenge we were solving back then for customers was like really collecting this information from like these very large environments and making sense of these distributed applications that they started to build. With a very strong focus, obviously, on performance. Back then, the Dynatrace's uniqueness was that we had distributed tracing back then, so we could follow single transactions throughout your entire environment, which obviously for big environments became quite key. When I joined the company, I was employee number 30, somewhere around there. So I was pretty much everything from supporting POCs with customers, helping them actually in performance analysis. I did a lot of performance analysis back in the day. So I remember traveling back then to a customer trying to fix a performance problem, which was usually our POC. So back then it was before APM, as we call the category back then, was really seen as this pill for our application is not working. That's how we got involved in a lot of these conversations. Very different to what it is today, where people think way more strategic about this. Yeah, different roles, helping customers do this, doing some DevRel, explaining to people how to we can tune software, then obviously moving more and more into product. And I'm really a product person by heart. So I really like to build products, like to see people use those products and how all the products can change people's life. And where we moved then is obviously once we had the data problem solved, we really moved into, okay, how can we make more sense of this data? Because as you can imagine, the more and more data you have, that's the bigger the environment gets, the more data you have, the more data you can ingest, the more data you would have to look to, which then also led to the second generation of Dynatrace. And we built like roughly 12 years ago. Very interesting. It was just when Docker and containers became a thing. That was still well, we have not the 10 years Kubernetes anniversary, but it was like 1 or plus years before Kubernetes really come out. Cloud was still very fresh. And back then we realized okay, we have to build something different. We realized there's more and more data, and we were training a lot of people, and I was even back then developing a training program how to make you a performance engineer in a week, like how to teach you how to analyze problems, how to find the root cause of an issue. And at some point, we then started to think, okay, if we can teach this in 1 week, and it's really a well-defined domain and a well-defined set of steps, why can't we make the software do this right away? And this then led to the creation of what we today call Davis, which is our AI engine, where we started to introduce anomaly detection and automated root cause analysis into the product, more or less taking the burden away from the operator to look at the millions and millions of alerts that they're getting, and like condensing it down into what we call a problem. A problem is more or less the impact versus root cause and showing you all the way there and giving you that complete picture. So usually what you would do manually, and which might take days, or in some cases actually even weeks to figure this out. That was like the second generation, what we did. And back then I was like working a lot, especially in the space, into building our Davis AI engine, introducing this new product generation. The very pivotal moment for me was when we introduced the product to early stage customers and we showed them that we can identify the root cause of a problem. The immediate question they brought up, but if you know what the problem is, why don't you fix it? Which is a very valid question. Obviously, if you already know what's broken, why don't you get it back to normal? And while the question was very obvious back then, and as I mentioned, Kubernetes was just appearing, so it was like all infrastructure as code and so forth. The challenge was that most applications back then were still running on like very, very bespoke environments, to put it that way. The DevOps movement was obviously already around. People were working more to like a programmatic approach, but it was still very early stage when you were looking at the applications that were running. But back then we started already with this vision. So can we now move to the next step to become from like reactive, presenting to you what's happening, to like really help to move into remediation and like self-healing. That's where we then started to develop in this field, to automatically try to resolve a problem, to detect what the problem would be. And again, also using, for example, predictive AI to know how to change an environment. And that kept evolving. And obviously now with infrastructure as code basically being the default way how we configure our environments, plus the availability of generative AI that easily helps us to rewrite our infrastructure as code definitions on the fly, like combining this all together, like the anomaly detection piece, which is mostly predictive AI, the root cause piece, which is causal AI, and now generative AI. We can now really build systems that really help the operator or the teams responsible for running the applications to propose how to change and optimize the system. So has also like been kind of my journey, because sometimes people ask me 17 years is like really long. But as you can see, the problems that we were trying to solve as an industry were continuously changing along that journey. And right now, I'm mostly focusing beyond other topics on how we can bring Gen AI into this mix of AI. How can we make things work together, and now eventually really deliver on this idea of self-healing applications? How can we get closer there?
Wow, really interesting answer there. And you touched on various different aspects of how the application stack has changed and evolved over the past decade or so. And I found interesting that you mentioned the three types of AI. Could you just repeat that for us again, the three
Yeah.
types of AI?
So we combine 3 types of AI, which we call hypermodal, because we use one AI actually to enrich the other AI. That's like not hyperlinked, but hypermodalities. First of all, you have predictive AI. Predictive AI, as the name implies, predicts the future behavior. So this is a lot of statistic methods. And once you can start predicting how an application should behave based on historic data that you have available, you can also do anomaly detection. So basically, anomaly detection is, okay, the reality doesn't match my prediction.
Okay.
This is very different from SLA management. To give you a very concrete example, you have a website and your SLA is 2 seconds. Usually that website responds in 200 milliseconds. If this moves now to 350 milliseconds, that is an anomaly because you expect this application to be faster. It would not be like an alert or an SLA breach. But still, as an operator, you want to learn about changes in behavior of your application because this helps you to actually become more proactive. And that's the whole idea behind anomaly detection. You want to understand the changes and then the impact of those changes in your environment. Because usually the first question if an application stops working, unless it's like for very obvious reasons, like a server is going down, a network link is going down, you want to know what changed. That's the first question. So that's predictive AI. This is how the system is expected to behave. This is how it's really behaving. Also then helping us later on with how do we expect the system to behave in the future, like what load are we expecting in an hour or 2 hours from now. Causal AI then takes all of these events that we created with predictive AI plus deployment events, changes to user behavior, changes to like lots of this, because as you can imagine, there's lots of events that you're getting in the systems, in some cases millions, which is impossible to just make sense out of them, or if it's not impossible, it will take you forever. The idea of causal AI is to like sort those events and put them in a cause and effect relationship. Like very simply, you have 3 services. Let's be technology-wise creative, call them A, B, and C. A calling B calling C. Service C fails, you will also see that B and A have a problem. So if you would not have any causal relationship between those, you would think, okay, all of those 3 services are broken, but they kind of all look the same. However, with causal AI, and if you understand the topology, how the system is actually structured, you can then explain to the user automatically, yes, C is having a problem, and A and B are just affected by this problem. This actually gets you 2 benefits. Number one, you don't have, actually 3. Number one, you don't have to do this manually because this is a lot of work to analyze this. And especially as we had this increasing complexity in the systems that we were running, when we were moved from 3-tier to multi-tier to like the massive scale that we are in at right now, it becomes even harder and harder. So you don't have to do it manually. Number 2, you are faster with the root cause problem resolution because you know you only need to fix C. And number 3, which is very often underestimated, you can tell the team A and B, yes, your service is having a problem, but you are not the one who can actually fix it. Somebody else takes care of it. I think it is very often underestimated because what usually happens, you bring everybody in the room, like the typical industry term used to be war room or whatever you want to call it, and all of them have to figure it out. But if you don't have to bring those people in the room, they can actually focus on something else. So now with causal, what we get is exactly, okay, this is the impact, this is the actual root cause. Goes back to the way, yes, you have an increase in response time because the new version that you deployed has code that was running slower. And now take generative AI into the mix. When we want to become more active, we know what we want to change in the environment. We know the root cause. We know when it worked, when it did not work. We might be able to actively adjust the environment. Like we know, okay, it would work again if we add more instances, if we change a configuration, or maybe even if we propose to like run an older version of the application. And now we can use like all of this information we have collected along the way and put it into what we call like a hyper prompt, like a very complex prompt. So these prompts are reaching usually the limits of what an LLM can ingest, and say, okay, please like retrieve more or less your infrastructure configuration and modify it in this and this way, assuming that the application then can work. Usually you don't do this obviously fully automatically. You just don't have software to change your entire environment and deploy something automatically. But think of it this way, if you got woken up at 3 a.m. in the morning, it's a massive difference waking up to 1 million alerts versus waking up to getting a textual description and even like a visual description of what went wrong in your application with a very concrete proposal on how to fix it. That definitely helps. It takes away a lot of stress and massively cuts down on resolution times. And in some cases, if you have runbooks for a certain situation, you can obviously even make this like work fully automatically.
Wow, really interesting there. So you're mentioning, the interesting question that your customers were asking, which is if you can identify the root cause, why don't you fix it? So, I'm trying to just understand how, monitoring tools have, responded to that need, where, have you, thought about how you can actually proactively make changes to fix issues? Is it in that direction, or is it more like we are just giving you very concrete steps like you just spoke about? Like if you take these steps, you can resolve this issue. So it's a summary kind of thing. And so, but the steps still need to be taken by the customer. Could you kind of explain a bit more on that part? Like what does it mean for you to fix the issue?
Yeah, I mean, we can also cover the preventive stuff. I think the preventive stuff that you can do. So we do some preventive operations. These are, I think, like bigger automation or more complex automation tasks. So a lot of operational automation is still, if this happens, do this.
Yeah.
Or if this system has this issue, do this. This is like very classic run book. There's like no additional cognitive work in there. So this is one thing
Mhm.
that you can automate. So you would link directly to a resolution process.
Yeah.
Very simple things, especially with older environments where we have seen customers doing very simple things, like even like restarting process, like turning it on and off again, basically, which sounds overly simplistic, but you have to figure out of like 100,000 servers or application processes, which one you need to restart. This is super helpful, like because they literally need to find a needle in a haystack.
Mhm.
This is like the first step, like of these processes. In some cases, it's actually harder to choose to even prevent the problem, and you can actually foresee some operational issues that even we can see. Like you might run out of disk space, or you see user load constantly increasing.
Mhm.
But then you have to decide, do I need to scale up or down? So later on, scaling down again, and by how much? Or do I need to like resize my disk? Do I need to reconfigure, I don't know, my workers for a certain process or so? This is usually harder to automate because it's not just based on an event, but you need to first predict, use predictive AI. And it does actually two things. Are you actually running into a problem and by when? And then how do you need to reconfigure it? That's the preventive part. So what the system then does, or what we then do is we kind of predict, okay, how the system should be changed. And if it's a modern system, we have the manifests available. It's a Kubernetes manifest. It's other infrastructure as code. We can actively propose on how to change it. Say, okay, increase the instances to 5, change the memory limit here, modify these and these pieces here, changing the thread pool, whatever. So you can actually derive this from the data, but you would not automatically deploy it in most cases. So not just proposing the resolution step, but you can be very specific. Okay, this is the change that most likely has the biggest impact, or the most likely is going to
Mhm.
work. You're not going to apply it automatically. Usually you create a PR for your GitOps repository and then execute it.
Mhm.
So you have like the very traditional runbooks, you can fully automate those. You would do it anyway.
Okay.
Then you have those where you have to do some additional work in between where you can use predictive AI to make it better with generative AI.
Mhm.
Then in the problem resolution phase, yes, you can obviously also propose something, but you can also learn from past problems. Like how has a similar problem been solved in the past? As you have this information available, you can look it up. Like the last time this service had a problem under like the same circumstances, this was the resolution process that was done. In order to do this, obviously, as well, you also need to have access to how the system changed. Because traditionally, what people did, you create obviously a service ticket and somebody was working on it. And if you look at most service tickets, you cannot really automatically reconstruct from the service ticket what was actually done to the system. But once you move to a GitOps infrastructure as code process and you monitor this in the environment, you can exactly derive how that system was changed. So this is where I would then propose, okay, the last time it was resolved this time, another time this was the issue. Which one of those do you want to pick and choose for resolving this issue? So it depends a bit on the situation, how much you can automate from fully automated to making an automation proposal to still giving the user options that worked in the past, but giving them the final decision on which direction to take.
Really interesting. Yeah, because there's also the aspect of where uh, where users may not want the observability tool to actually take action. They want to be able to approve all of the actions, and it's good that you have that choice there. That's really important. And it's interesting also that, today there's a lot of talk about AI, but since before that itself, machine learning was more the thing. And I think a lot of this predictive analytics came under machine learning, the broader umbrella. And I think AI is sort of layered on top of machine learning, probably, where Gen AI, especially because these days, uh, yeah, but I think you guys have been doing AI since 12 years ago that you started. You brought out Davis AI and you're working on machine learning. You didn't call it AI as much, I guess, but then you guys already had uh, that that foresight and vision to start back then. You mentioned interestingly that you're also working on integrating Gen AI into causal and predictive AI. What does that involve? You've probably given us hints about that in your previous responses just now about things that Gen AI is adding to what was already there. Tell us a bit more about what does it mean for you to actually integrate Gen AI into previous versions of AI.
And so we do it in a couple of areas. Like one area is we introduced what we call like the Davis Copilot, which allows you to actually ask questions about your data.
Mhm.
Because the biggest challenge people have is not that they don't have the data, but they don't know how to access it. And it actually does two things. It allows you to ask a question in natural language, and then finds the right answer in your data for you. And especially when we talk about monitoring data, it's not always that obvious where the data is. So a lot of people think, oh, you create your query, in our case, DQL, Dynatrace query language, but it actually does way more than this. First of all, it learns the structure of your application. Because if I would ask, hey, show me how Twain's Kubernetes clusters are doing, this is a question that's not that straightforward to answer. Or if I would even ask where the most recent deployments happened, and like very environment-specific queries. So we use GenAI to even find the data, like because sometimes it might be in logs, sometimes it might be in traces, sometimes it might be a metric, and you as the end user might not even know where the data exactly is stored. So what we're doing will allow you to ask, okay, this is the answer that I want to get, and then use that combination of GenAI to understand what the question is, but then go back to like that topology model that we have that we call Smartscape that causal AI uses to even figure out what you meant by this question, how it can even be answered, and then help you to better and faster access the data. That's one use case. The other one is a bit helping mass customization of monitoring data. So usually what you get in very big companies, we have companies that run thousands of applications and they have a central monitoring or platform team, whatever you want to call it. So they're becoming more platform engineering teams right now. The challenge though is that you get like these very generic dashboards. In some cases, you get some templates that you want to update, but the challenge with a template is you can just replace small bits and pieces. And the example I like to use is how would you, for example, automatically build a dashboard for your most critical Black Friday services? This is nothing you can template. So there, I think you also see the interaction of the different AIs. So you take that input, Gen AI would derive, okay, find me all services that are critical to my conversion rate. That's basically what that means. Then you go back to causal AI and find like all services that are related, or more or less all user journeys that lead to a conversion. And then you derive, okay, these are the software services that are used. Then you ask predictive AI, how are they most likely behaving under high load? Or did they were part of a problem in the past? Then you package the most critical ones up, and then you use this again as input for GenAI. Build me a dashboard that has these and these metrics of these and these services there, and maybe then even create some additional custom alerting and notifications on top of it. So this is like how AI plays together. I think GenAI is very good in like having this human interaction interface and creating some sort of output, but even in like when, for example, OpenAI introduced tools, or when you have more agentic approaches that use like other tools, that GenAI goes to ask like for very specific knowledge. Like in our case, what are the components that do X? or to predictive. How would this component behave under certain circumstances? The same way you would not use GenAI to replace a scientific calculator, it uses it as a tool as well. And that's how we that's how we see these things actually emerge and play together. The other area is like really when we talk about automation based on problems, where we get in, as I mentioned before, infrastructure as a service code, Kubernetes manifests, and we know what we need to change. To actively propose the change, so the workflow there is we find the issue, we find a potential resolution using predictive AI and building a workflow on this, and then creating a PR for your Git repository. Okay, this is what you would propose as a change, not automatically committing it, but it makes your life much easier because you have almost the whole workflow laid out. And instead of being in the role of being the one who has to do all the work, you're in the approver committer role, and all that other manual work is done. And as you're combining it with other sorts of AI, the basic massive advantage is that the system can explain back to you why it's doing this. Because if you just get a proposal, okay, change this in your environment, it's like, okay, I can believe it or trust it, or I can't trust it. But how do I know? And especially the advantage of causal AI is that you can ask causal AI, why do you think this actually would solve the problem? Same to predictive. Why do you think 5 instances would be enough? And can get this information that also builds your confidence to take the decision. So you either accept it or then still try to override it. So that's how they like play together. But GenAI really has this role on the one hand of being a new interface and generating what I call like mass customized artifacts for monitoring. And dashboard generation is really a key one. Like nobody likes to build a dashboard, but everybody wants to look at them. Sometimes joking, I never met the person who said in the morning enthusiastically, today I'm going to build 3 monitoring dashboards. Like nobody ever said that. Still, they want to have them. And it's also why people keep them because they are so valuable. But I think we have to get more into the situation, more like what individual needs are of the people who are working with the application. And then obviously actively driving this resolution with infrastructure as code is where I also see massive potential for what how we can like really accelerate this process by really changing, like to repeat this, the role of the operator, not trying to figure out the solution, but reviewing a proposed solution and adjusting it maybe to some specific characteristics that you want to.
Wow, really interesting. In a minute, I was wondering if you could show us, visually some of the things that some of these features in action that you were just describing, and make it real for us. But yeah, just before that, even just want to mention how it's fascinating how Dynatrace as an organization has moved from, like you said, APM at the start to now being more platform operator centric, and moving from just application monitoring to now more infrastructure and system monitoring. Quite a journey. Could you tell us a bit about just that shift and some of the different roles that Dynatrace is relevant to, and how it's relevant, as you were just mentioning as well? What does each role need? How are their needs different? Could you comment a bit about that?
Yeah, so I think the initial audience when we started at the very beginning with Dynatrace was really developers. Because developers back then had the problem, they had to reproduce everything on the local environment. And when we for the first time showed them a trace, which is like almost like debug stepping through your application from a live production environment, from the actual transaction that failed, that was, wow, how does this even work? Like this is magic. So I don't need to figure out how to reproduce it. No, you look exactly what failed in production. So that was the first challenge we were solving in the very beginning, and we still do this today because I think reproducing errors is getting harder and harder. Back then, at least you could reproduce it, but today the entire system is changing because you have all those individual teams that are responsible for their own services that have their own release cycles. Almost the system that you're looking at is constantly changing. So this became even more relevant there. So these are the developers, and then you have really the SRE teams who have to run thousands of applications. So they don't have details about they don't have detailed understanding of all of those applications. They can't. Like nobody of us would be capable of understanding thousands of applications. And also the load keeps increasing. And for them, the value is, if you would have to look manually at it, you would have a very weird curve, because for every new application, you would have to bring new people on board. And this at some point turns into a hockey stick. So it wouldn't even scale. Then you would have like 1,000 people in your SRE team. So the more you can automate and take this away, this is what we're doing for those teams. Now, obviously also transitioning more into helping them in the resolution process. Also, security teams are blending in there more and more. So we also have integrated security with observability, because at the end of the day, if you're responsible for a production environment, it doesn't matter whether your application is slow or you have a security vulnerability, you need to fix it. And it's usually the same team that interacts with it, and also bringing security people more and more in. So also working with them and bringing a new angle to it, because we know end to end how things work and can put them way more into context. Log4j was a great example. Like everything was affected, but you can't modify everything at the same time or can fix everything at the same time. So what is most critical? We provide insights telling you, okay, this is not public facing, or this is not accessing any database. And suddenly you can start to like have your own like way more informed CVE score about the problem, where to start, where to find those things. So that's where the security teams come into play. And then we also have the DevOps teams that specifically care with the rollout of applications by introducing what we call a site reliability guardian, like watching new releases going into production, doing progressive delivery rollouts, but also automating them, like not watching whether the application is working or not, automating this, and even adjusting your rollout strategy based on error budgets you have on services. Like Monday would be rollout day. But why is Monday rollout day? If you just had an outage over the weekend and your error budgets are down, you wouldn't roll out on Monday, or even being able to capture it very, very early. So we really span like across this whole set of audiences. And what I think just recently emerged more and more, as more and more businesses are digital right now, people started to realize, well, we have all of the information of our business in our monitoring systems. We know about conversion rates. We know where users are coming from. And like lots of this information is there. And we see more and more users extracting this directly out of the monitoring application and even building business-facing dashboards. While the business audience might not be like the direct user of it, they're like indirectly consuming the information that monitoring tools provide. And there's like interesting examples where people are looking at user journeys, like from mobile to point of sales, understanding how users are interacting. And we had like one customer who figured out that, yeah, most people actually order online, but then pick up in store. And that's usually the time in between from when they order something on their mobile phone and when they show the QR code in store and want to pick it up, which then even helps to drive their business decisions and how they actually need to structure their store. To also airlines who used OSS for monitoring, figuring out why like the airline terminals are not working, but then even driving a business process behind it, because they told us because they're renting these terminals basically, and the connectivity and everything, realizing, okay, if people cannot check in at the check-in counters, at the automatic ones, we actually need to trigger, based on that issue, a process that actually sends more people to the check-in counters, because the natural thing is, if you can't check in at the automatic counter, you walk over to the regular check-in counters, and if there's then two people there that usually would satisfy the requirements for 80% check-in automatically, you would have to change this. So I think the audience scope is widening, like really from developers, SRE, DevOps audiences, and then more critical business processes running it as also for a business audience that's getting more and more interested in the data, but all at like a different level of abstraction that they're looking at the data.
Some really interesting examples there. And talking about examples, I was wondering if we could dive in to see some of the new features of Dynatrace in action.
Yeah.
Could you show them?
Yeah, just give me 1 second over here. Dynatrace actually looks for you when you jump into the Dynatrace UI. So basically, Dynatrace is structured around what we call applications. So why does this exist? If you look at a lot of monitoring tools, you have everything in there. But as we talked about different audiences, I might have go into like my security overview if I'm responsible for security. For an SRE, I might dive into like problems in my environment overall. If I'm a Kubernetes admin, I might jump right into like just the Kubernetes applications. And here we would then also have like, for example, workflows if I'm more on the automation side. So like really focusing on other people. The first thing we will realize when we look actually at problems is, and we mentioned like that the topic of problems and anomalies and errors. So problems like build this end-to-end chain. That's why obviously I can cut it down to active, but I can ask questions very vital. What should I deal with first? And what you see here is the category on the side where we say, okay, this is just informational. We don't care about them, right? This is availability. This is error. These are errors. Okay, we would definitely care about errors, and we would care about availability issues. So this would immediately cut it down and everything that's happening underneath. So that's usually even like how you would like prioritize, because prioritization, especially with large environments, is a key feature. You don't very often don't know where to start and what's really the most important one. I can then even limit it down even more. Is this just have an availability problem in the infrastructure, but not affecting my end users? It will get a lower priority than something that's directly influencing my end users. And yeah, and here I have a very concrete example of what this problem then looks like. I just prepared this up front that we don't have to search it for here now. And what we see here is we have the number of affected applications, services, but we also see the number of affected users. So when we talk about remediation, we do not only talk about remediation that we fix the infrastructure, but assume these are people who wanted to check out in your checkout process. So you want to actually get the name of those people, which you could actually if you wanted to do so, and then directly push this into a CRM system so that somebody actively reaches out to these people and say, hey, sorry that you couldn't actually check out here, but let's try to fix it for you. You even have the ability here to do what we call like replay. This is more, okay, what actually went wrong for these users? And I even have the ability to visually, okay, I didn't install it on this browser here, but I would have the ability to even like visually, like as a video clip, even show what was going on here. Then I see, as I mentioned, like the impacted applications. I could obviously also use this for collaboration, like telling me, okay, what else is going on here. People could add comments on this. You could obviously link this to your service tickets and so forth. And then here on the right side, very interestingly, it tells me what the root cause is. Like out of all of those services, it says, yes, this is the root cause. By the way, there was a deployment of a new version, which was impacting exactly a failure rate on these services. So if my entire infrastructure would differentiate, okay, this is the root cause, this is who was impacted, showing me all the details, all the way over to the root cause. This is nice by itself, but what I can also do is, okay, asking now, actually Dynatrace, like how did this really happen over time? Because very often when we see, or when we have to deal with an application problem, things are already broken. The first question is, how did things actually happen? Like, how did things break? And then later on, how do things recover? So, and now I have the ability to actually replay, that's also the explainability, how individual components in my environment failed and were able to recover based on the actions that I was taking over time. So I can really get that visual explanation. How did we get to this situation? That's exactly the topic where we discussed about explainability, and then obviously also trust in the system to understand this. And this usually for the people responsible for environments is always key to say, okay, this failed here, this failed here. And also when we're talking about AI, this is what we consider obviously super critical for people, because they why should I trust the AI? And very often people in the beginning said, yeah, I want to validate what the AI is doing, which is totally fine. And very understandable. But as they see the AI doing exactly what they were doing, or in some cases even taking a better decision, they build up this trust and then delegate more and more of the responsibilities to the AI system itself. And what you've seen here is like really that that magic behind, that magic behind of like how we're doing this root cause analysis. And obviously now the obvious next step would be then linking this in a workflow to like an automatic problem remediation. Like, okay, if this service failed, like this deployment, then take it back, go back to the last known good version if this is something you want to do. Or like take that, if it's an AB deployment, then switch back to a blue-green deployment, switch back to the version that was previously working. So that should give you a rough idea of like how AI and Dynatrace is working and how this then would obviously also tie more into the Gen AI piece.
Wow, very interesting. Uh, that's quite interesting and good to see that, there's different dashboards for each role, and there's just the root cause analysis. That section was really helpful as well. So yeah, I see that, there's just a lot of data in there, but there's really attention to detail and how it's presented and how it makes it easy to take action on and get to what you need to actually do. That's something that I really liked from this demo. And as we wind down our conversation, Alois, I just wanted to get your views on looking ahead for the next year or two. Where do you see the space headed in terms of what's coming up next for the whole space of observability, or just for Dynatrace? What are you guys most excited on? What are you working on? Could you give us some closing comments as we look ahead?
I think what we see overall in the industry is we want to make running and managing applications more and more a commodity and really focusing on developing the code. There's like multiple ways the industry wanted to work on this, whether it was like the mantra behind Cloud Foundry, where you see things like autopilot on Google Kubernetes. What we will see is that a lot of these operational tasks will be taken over more and more by a combination of the monitoring and the infrastructure tools. That's where we see the push. When we talked, like we had our annual conference in February this year, we see most of the strategic conversations of customers. They say, well, we want to have a zero incident policy. We want to move more and more into remediation and so forth. Which is also funny for me because when we started the whole AI work like 12 years ago, the feedback I got for the first conference that I wanted to speak about, you can't tell people that AI is going to do the analysis or the work of operations people. You can't talk about this. And today is exactly the other way around. Like, tell us how AI can actually help us to do more and more of this. So I think that the longer term vision is always like optimizing or self-healing systems, self-protecting systems, and also self-optimizing, like really focusing on performance and just availability related tasks where the systems take more and more of those steps automatically. We've come closer now by being able to automatically propose those steps. Doing the same on a security side. If you find a security weakness or an intruder, you are taking active actions, which obviously to some extent is already done today. And then on the optimization side, either doing it from a cost or an environmental sustainability policies. I think where these systems are like really moving is becoming co-pilots and assistants. So they don't expect the human to take all of these decisions. Like if you're managing a bigger team, they're bringing facts to you, they're bringing proposals to you, and bringing whoever's running the applications into a role to actually just validate the decisions that others are doing, automating some if they're not critical. And I think that's the main change, and also the change of the job of the people who work there. I mean, we have to be aware that for decades we have been using people who have a degree in computer science, like very highly skilled people. And what we wanted them to do is, and I'm exaggerating a bit here, look at dashboards all day long and then press a button every now and then. Like it was a massive waste of talent. Now we can get them to do a job that they are way more qualified for, like moving all of this. You don't need to look at the dashboard. If something really interesting comes up, you get the information. You get it in a way that you can take decisions. So that's where I really see things moving in the future, that they have a very small operations team that can cope with these very large environments. And their work really changes. They're not like doing that very, I mean, still important work, but still work that we can automate, just looking at something, and processes that can be automated to way more high value work also for the company. Yeah. Sometimes joking, like nobody ever got promoted for keeping systems up and running. I think a lot of people know this, and they also want to work on something else. So that's where I see this, that the shift really goes away from keeping systems working, and also we'll see a massive productivity gain there. But that's where I really see this, where the shift in work that's happening in there.
Really interesting. Yeah, it ties back to what you were talking about earlier, about abstracting data so that it's more actionable. So yeah, more of that coming up. As we finish our conversation, Alois, I just wanted to end with asking you a question that I ask all of our guests at the end of the show to get to know you a bit more. Just what would be your alternate career path if not for your job in tech?
I think I would most likely have become an interior architect. Because I really like interior design. I think that it's also kind of like related to software. You like to create and build something. And with all of my apartments that I have, I put a lot of emphasis into there. I like to create something that you can like use on a day-by-day basis.
Mm.
And I have just found myself like when I moved into like my first place, my second one, like always spending more and more time, like getting more and more involved into this. So yeah, I would most likely be an interior architect, or and always been interested in architecture and how you can design places for people to live in to like really support their everyday lives, more in the physical world versus in the digital world. What I'm doing right now.
Yeah. Would you say you lean more towards form or function?
I'm a big believer in form follows function, and if you do it well, uh, I think you need both. You need to feel comfortable. It's the same for software. You can build the most functional piece of software. If you don't like to interact with it, it's not worth it. We spend just too much time there. And I think that's also always also the delicacy in building like even software. You need to bring those two together, and things need to feel natural for people. That's also like even in software, yes, you need documentation, but the more the process feels natural to you, the less you need to think you need to learn something. And especially in software, we see it. Who's reading manuals these days? Like nobody does. We're used to more and more consumerization of topics, like in that whole process that I've shown you before. Like we had this mantra back then when we built it: follow the red. It's very simple. Click where it's red, and it will eventually get you there. And I think that's the same in architecture. I remember this when I had like this tour of like the Getty Museum in LA, where it's very obvious where you should go, where you should not go. So I find it's like super fascinating in also in architecture, like how you can design a place where it becomes natural where to be, where not to be, like how that it feels like they don't have to
Mm.
think about it. That's what also fascinating me when about architecture, how people like build spaces that you don't like need to be guided, but you're almost naturally gravitating to where it should be.
Yeah, yeah, yeah. Intuitive, I think, is the word that comes to mind. Uh, Fascinating. Thanks so much for joining us today, Lois. It was a pleasure chatting with you about all things observability and especially the intersection between observability and AI. Quite amazing to know that Dynatrace has been on the ball since 12 years now, and that it's not something new for you. Pretty exciting stuff what you guys are doing there. Thanks for joining us and sharing about this today. It's a pleasure having you.
Yeah, thank you for inviting me, and also thanks for the great conversation.
All right. And to all of our listeners and viewers, we hope you enjoyed this conversation. Definitely head over to Dynatrace's website and check out what they're building. Check out their Davis AI if you haven't already. And just, yeah, look at all of the other features they have. As Alois was mentioning, the the ease of creating dashboards and just the way that their approach to observability that makes it really actionable and with a focus on actually solving the root causes that are found. We hope you enjoyed this conversation. Do tune in again for the next episode, and we'll see you on that one. Thank you. Bye-bye.